So this will be an animation for the Grahm-Schmidt process. You can see here three vectors, three linear independent vectors, v1, v2, and v3. And what we're going to do is to convert these vectors, which are now not orthogonal. The angle between them is not 90%, 90 degrees, and we are going to convert them to be orthogonal to each other, namely 90 degrees between each of them. And also, the Grahm-Schmidt does that, but we'll also take it one step further and convert each of them to an orthonormal vector. So for each vector, we will convert it to we will take off all the projections to the previous vector that we already worked on, and then convert the vector to a normalized vector. Then move to the other vector, take out the projection from all the previous vectors and move on. Let's see how it works. So you can see here v1 is right over here. You can see that we convert him now to a unitary vector, and now we're going to v2 will take the projection from v1 and take it off. This will be like this. We don't need to work with v3 because we didn't do anything to him. Now we're going to v3. We are taking off the projection from both of them because they are the previous ones, and we are left with this one, and then we convert it to a unit vector. This is how we got now three vectors which are orthogonal to each other. We also normalize them, but you can see that the angle, if you could just measure it, the angle between each of them is 90%. This is exactly what the Grahm-Schmidt needs to do. He converts a linear independent set of vectors into an orthogonal set, and in this case we also normalize the vector. This is the idea of the Grahm-Schmidt process, and this is how it is done. I didn't show you the formula, but this is the core idea, the theorem behind that. Thank you all very much, and that's it.